ellipse is a set of all points in a plane such that the sum of the distances from P to two fixed points, F1 and F2, is constant, and the fixed points are called foci. So when you look at this animation, the F1 and the F2 would be the, I'm going to go to this one that's already like frozen. The F1 and the F2 would be the push pins. And then this distance would be like distance 1, and this one would be distance 2. And no matter where the pencil is, if the pencil's up here, the distance 1 is different and the distance 2 is different. However, if I add D1 plus D2, it's always a constant amount. It's always the same amount. So that's what it's talking about. So that every time we add these together, every place that we add those together, here's another D1 and D2, every place that we add the D1 and D2 together, it's going to be the same amount. That's going to create this ellipse. For the formula, the graphing form of an ellipse, there's two kind of similar but different formulas. And the only thing different about these is where A and B are located. And I really don't want you to get hung up on what A and B is. I think if you just actually think about the numbers, it's going to be a lot easier. But it's hard to explain it without just throwing some variables in to start. So in each of these, A is just going to be the larger number. So in the first one, the larger number is under the x squared. And in the second one, the larger number is under the y squared. So that's what determines what A or B is. The big one's A, the bigger one's A. What if they're the same? If A equals B, then it's a circle. So they have to be different or it's not an ellipse. Okay, if they have the same amount, then it's a circle. The center is at HK just like it was for the circle. And then what's different about this equation is it equals 1 where the circle equaled the radius squared. But we don't have a fixed radius for an ellipse, so we just have it equal 1. Some vocabulary, the major axis contains the major vertices. It contains the foci. It's the longer axis, and it has a length of 2 times A. And then the minor axis contains the minor vertices. It's the shorter axis. It has a length of 2 times B. The foci have a length of C units from the center. And to find C, we use A squared minus B squared equals C squared. So this one's minus. And they're always on the major axis. They're always inside of the ellipse, just in case you get some dots that are outside of the ellipse, something's wrong. Okay. And then the last one, I don't know why I thought I underlined that, but eccentricity is a ratio that just measures the ovalness. And I took that out of the book, the word ovalness of the ellipse. And the ratio is just C over A. And it's just a ratio that compares the foci to how far the major vertices are. So here's the first example. You want to make sure that this is in the correct form. And I'm going to tell you it's not. What is wrong with this equation? Christopher. It doesn't equal 1. So it needs to equal 1. To make it equal 1, I'm just going to divide everything by 9. So my center is at, there's no H or K, so 0, 0. Now the major vertices have to do with the bigger number that's under either the X's or the Y's. So I look under the X's and there's a 9. Under the Y's, there is a 1. So when I square root, these are like A squareds and B squareds. When I square root those, the bigger number is 3. Bless you. So the major vertices are going to be horizontal because they're under the X. All right. So I'm not going to really focus on what A or B is. I'm just going to say which one's bigger. That's the major one. And so it's under the X. That means I'm going to take my center and I'm going to add and I'm going to subtract 3 to 0, 0 on the X. I'm going to get the ordered pair negative 3, 0 and 3, 0. I can do it graphically also. I can go to the center and go 3 to the right and 3 to the left. And I know it's right and left because that 9 is under the X's. The minor vertices would be the smaller. So the smaller one is under the Y. So I'm going to take the Y value of the center and add and subtract 1 to it. 0, negative 1, and 0, 1. Or I could go to the graph and go up and down 1 unit from the center. The foci, we use the equation c squared equals a squared minus b squared. So the a squared minus b squared, again, you don't have to think too much about what a and b is. You can only subtract big number minus small number to make this work. The big number is the a squared, so 9 minus 1. So c is the square root of 8 or 2 radical 2. But for the foci, they are that many units away from the center. And it has to go in the same direction that the major vertices went. So since the major vertices were the x's, I'm going to add 2 radical 2 or subtract 2 radical 2 to the x's. But I'm doing it to the center. So I'll have negative 2 radical 2, 0, and positive 2 radical 2, 0. And that amount is just under 3. Could type it in my calculator and find out exactly. But I know it's just under 3. 2.8. So from my center, I'm going to go out 2.8 to the left and 2.8 to the right. And it's kind of hard to see because it's almost the same color as the purple one. I'm sorry. The purple and the blue are like right next to each other. Again, kind of difficult to see. The eccentricity, we do C over A. So my C value is 2 radical 2. And my A is 3. There's no reason to reduce. I mean, you can't reduce that. And then to finish just graphing, you might want to envision a rectangle that passes through those vertices. And then as you connect these, you want to kind of connect them so that they hug around that corner. Okay. And that's it. Not too bad. Yeah, not too bad. Okay. So the next one is already in the correct form. So we can pick out our center point at 1, negative 3. And then I'm going to look at my major vertices. I'm going to look at the 25 and the 36, and I'm going to say which one's bigger. 36, square root it, 6. That's under the Y. So my major vertices are going to go vertical. I'm going to go up 6 and I'm going to go down 6. So you could do that using the graph, or we could use our ordered pair to just add or subtract 6. And so my B value, my smaller one, is going to be horizontal. I'm going to add or subtract 5. So just from the graph, you just count 5 in each direction. Or I'm going to add or subtract 5 to the X value of the ordered pair. So to find C squared, I'm just going to subtract 36 and 25 and then square root. And that gets added to the center in the same direction that the major vertices were added. So that's going to go up and down. So I'll be adding or subtracting square root 11 to that -3. So I have 1, -3 minus square root 11, and 1, -3 plus square root 11 for my 2 ordered pairs. And I just used my calculator to find out that square root 11 is about 3.3. So from the center, I'll go up and down about 3.3 for my foci. The eccentricity, C over A, so we'll do square root of 11, and my A value is 6, square root of 11 over 6. So the eccentricity, if I could just look at that for a second, I typed that square root 11 divided by 6 in the calculator. It's about 0.55. The other one, what's the other one? 2 radical 2 over 3, or square root of 8 over 3. That one is about 0.94. So what the eccentricity is saying, that 0.94, is that foci is about 94% towards the end, where in this one it's about 55%. It's a little bit over half to the end. Which one looks more ovalish, like more stretched? The first one with the bigger eccentricity. Okay. Okay, next one is not in the correct form, so we got to change the form first. So we're going to do complete the square. All right, I'm going to put my x's, my y's together. Okay, so I'm going to go complete the square, but I cannot do that right now. Can you tell me why I cannot complete the square right now? Tracy? Yeah, I cannot have a number in front of the x squared or in front of the y squared to do that complete the square b over 2 squared trick. I can't have a number there. So I'm going to go ahead and factor that out. So I'll have 16 x squared plus, what is it? 6x. But this is not going to be a square anymore because that's a different number. If you watched my video, then you will know what I'm talking about. I'm going to pull out the 4 from the second one, y squared minus 2y plus fluffy cloud equals negative 84 plus, I still have squares on this side. So I'm going to fill in a 9 in my first spot, but 9 does not go on the other side. What goes on the other side? 16 times 9, 144. And then I will fill out a 1 here, but 1 does not go on the other side. It's 4, yeah. So my fluffy cloud and my squares are different numbers. Now I can factor. So I get 16x plus 3 squared plus 4 times y minus 1 squared equals 64. Now, before I go to the next step, you obviously not yet, but when we get done with this stuff, not today, but when we get done with conics, you're just going to have an equation like this, and you won't know if it's an ellipse or a circle or hyperbola or parabola. Well, you should know, actually, by then. But what I'm saying is, as I'm factoring here, I can actually tell that this is not going to be a circle. Okay? Because there are different numbers with the x squared and the y squared. So the radius wouldn't be 64 here. If I divide everything by 16, I'm still going to have a fraction left in there. If I divide everything by 4, I'm still going to have a number in front of the first one. This could not be a circle. It would be a circle if it was like 16 and 16 and 64. So I could tell this is an ellipse. And because it's an ellipse, this has to say 1. So I'm going to divide everything by 64 instead of whatever else I was saying before. Okay, so we'll have a center at negative 3, 1. And how about I stop talking, see if you can fill in some of this stuff yourself. See if you're understanding it. I will fill it in a moment, though. Does anybody have a charger? You know, there's this thing, it's old-fashioned. It's pretty old-fashioned, but paper. You know, try these together with us. Find information. So the major vertices are under y. So I will change the y value in the center. My c squared equals a squared minus b squared. I get c value of 2 radical 3, which is about 3.46, and that's going to go vertical. And just looking where those dots are, I feel like my eccentricity should be close to being 1. So the eccentricity is 2 square root 3 over 4. So square root 3 over 2, which is that doesn't make sense. Did I put it in the wrong place? What? What did I do wrong? C over A, right? Yeah, right here. 2 radical 3. A squared is 16, so A is 4. Oh, that's right. I don't know why. Oh, I typed it in wrong. Oh yeah, that's a better number when I typed it in the second time. What? Say it again. Eleni, I didn't hear your question. So the eccentricity is just telling us like that this is going to be more of a it's about 0.87, so it's going to be closer to an actual oval ellipse, less than a circle. That's what it's telling us. Okay, try one more. See if you can do it all. I can put this back up. For anybody who is still copying that, try one more. What are you confused about? You look confused.
So the a squared minus b squared. You didn't square 16 before.
What? Because a squared is already 16. So this number down here, these are a squared and b squared. These are the a squared and b squared. Yeah. It's just squared. And then we add the square roots to find the vertices. We add like the square root of 4. That means 4 square root of 4. And then put on the square root of 2. Oh, I'm sorry. There was just like a plus sign thing. That's all. I don't need to. I just I like to see who's understanding things, so that it's not like confusing later why this person doesn't know what they're doing. I'll figure it out before then. Complete the square. You gotta take out the 25 before you can do complete the square. But you don't take out that step. What did you divide by 25? Okay, I'm gonna do it in a moment if you didn't get, yes, you only divide the x's by 25. I'm gonna do it in a moment if you didn't get the complete the square stuff down yet. I'm gonna do it in a moment. Of course, if you don't complete the square correctly, what is gonna happen in the rest of the question? Something all wrong. That's why that complete the square assignment, got assigned to you. Okay. So I'm just going to go over this again like I didn't just do another one, just in case you need it. I'm going to rearrange it. So I put all my x's together. If you don't need my help on this, you can keep finishing it. You can even work ahead if you want. Okay, in order to complete the square, I cannot have the 25 in front of the x squared, so I'm going to factor it out, but it's not going away, it's just getting factored out. And then we take that middle number, -4, divide by 2 squared, just 4. But that is not a square. So I have to multiply the 25 back in and put 100 on the other side. In the other square, that one I didn't have to factor anything, so I'm just doing -2 divided by 2 squared, so 1. So I just have to add 1 to the other side. Then I factor it and add together what's on the other side, which is 25. And this is an ellipse, so it has to say equals 1. So I will divide everything by 25. And so if you worked ahead and if you got the wrong equation, you're going to get a lot of stuff wrong. So my equation that I had was x minus 2 squared plus y minus 1 squared over 25 equals 1. So my center is at 2, 1. The major vertices, I'm going to take the bigger number, and it's under the y. I'm going to add and subtract 5, the square root of that 25. Minor vertices, I'm going to add or subtract 1 to the x's. The foci, I have to do 25 minus 1. Square root of 24 is 2 radical 6. And that gets added to the same thing that the major vertices were added. Oopsie, too far. And then that 2 square root of 6 is just under 5. 4.9. The eccentricity will be 2 square root 6 over 5. And I'll graph everything. And my eccentricity is quite a big number. It is, well, big, 0.98, close to 1. So this is really ovalish, very ovalish. The last few questions about this are just problem solving, and I don't know that we'll get through every single one of them, but I don't know if we need to get through every single one of them. Just looking at the first one, here I'm telling you that the foci of this ellipse, we have it 5, 4, and negative 3, 4. And the major axis is 10 units long. We have to write the equation. So I need the center and I need the a squared and the b squared. So by this information, what's one thing we can pick out? Problem solving, what's one thing we can pick out from this information? That x is the major. Okay, so under the x is going to be the bigger number. What was something else? What do you think? Oh, the center. How do we find the center?
Well, you know it's 10 units long, so you know underneath, like, the a squared will be 25. You have to go 5 each way.
Okay, so a is 5. So a squared is 25. So underneath, and we already determined that was the x. We're going to have 25. Okay. We should be able to find the center. How? Marie? And if you just average the x's and y's, you find the midpoint, then you'll have the center. So between 5 and negative 3. So we'll have 1, 4. So I just need to find b squared. Problem solve that. So only one person in here knows how to do it. Cross multiply what? Okay. Well, thank you for saying something. Eden. Okay, the foci equation is c squared equals a squared minus b squared. And we know a squared is 25. But I don't know what c squared is. You have it as 4. You have c squared. You have it as 16. So how did you get 4? You went over here and you said, how far apart are these? 4. Or you used your distance formula. So 25 minus what is 16? 9. So you have to problem solve these. You cannot rely on somebody else to tell you what to do. You have to think through these. Okay? Let's try the, I think it's the 4th one. D. Is there a D? There's a D, isn't there? Okay. Yeah, let's try D. Let's see if you can problem solve through this. Sanjay, tell me something that you can figure out from any of this information, just something. Okay. How are you going to figure out the center? What's that? Use the foci and then do what with it? Okay. Do you guys have to use the foci for finding the center? You can. It's actually easier, but you don't have to. Abby, can you add something on? Doesn't have to be off of what he said if you were thinking about something else. Of what? Which two? The first two or the last two? Okay. So the midpoint would be -2, 8 plus -4, 4 divided by 2, 2. And what is that? That's the center, okay? Now, does anybody see why I said using the foci is actually easier? Because we're going to add or subtract the c value. So you can see the center. You can see the center in the foci here. Or on the other one, you couldn't. Either way, you're getting your center. Oops. At a -2, 2. Ryan, can you add something on to this? The a squared? Yeah, it's the c squared is 27. Now, he got that by taking this c value and squaring it. Okay, so c is 3 radical 3. I need something else that should be a little obvious. Nobody said yet. Gavin. Well, I need a squared and I need b squared. I don't need c squared, but I might need it to find one of those. But I should be able to find one of them right now. Abigail?
A squared is 36.
And where are you getting a squared is 36 from?
The distance from one of the or both of the endpoints to the center is 6.
Okay. So the distance from each of these major endpoints to the center is 6. So then our a squared is going to be 36. And I need to know where to put that in the equation. So I'm going to call back on Gavin now. Under the y, right, because it's up and down. Good. All right, we got one more thing to find. Lainey.
Under the x is 9.
How?
Because you take the c squared equals a squared minus b squared, and you get 9.
Good. Okay, problem solving. These other two are just really similar to those. If you want to try one and you know, double check that you're doing it right, you can ask me. Otherwise, I'm going to stop doing the notes so that you can start maybe the first couple questions on the assignment. So the plan is, it's a big plan. The plan is that we're going to have a short quiz on circles and ellipses next time. Okay. Also, on your modules, I don't think I have the module open. Let me find the module here. On the module for today, I gave you guys some leniency and trust because some people said that they liked on the last test that I did not assign questions so they could do what they needed. Okay, some of you that didn't work out so well. Some of you it worked out great, okay? So I'm kind of doing that again just to see. I've given you a worksheet for circles. It says do what you need to be ready for a short quiz on circles and ellipses, okay? I will post the answers. Then I've given you a book assignment for ellipses. And this is like if we were on normal days, not block days every single day where we had to do like 2 assignments every single day, this would be the assignment, okay? But since it's like 2 assignments together and I'm going to throw a quiz at you here because it's like the end of the quarter, I don't want to overdo it with, if you don't need all that work, then you don't need to do it all. But if you do need to do it all, then do it all. It's not something that should take you a ridiculous amount of time. But do what you need to be ready. Okay? If you only do question 1, you're like, "Yep, I got it." It's probably not enough, it's probably not good enough because you know the harder ones get towards the end. So make sure you jump around, try a couple of them. Okay? You'll just post whatever you do. It'll be just like turn in whatever you've done. And I will post the answer keys for you so you can check them. Okay? So again, this is a little trust thing. Do what you need to do to be ready for a quiz. Okay?